चलिए ठीक है, let's start. Starting with we're going to start with the first question. Reverse में start करें, ठीक है? Organic पहले कर लेंगे. So the first one over here is you're being given a question that onions are peeled, or there's a molecule. Which tests give a positive reaction for the organic product? So the organic product that you have is an aldehyde. It's a 3-carbon atom aldehyde. तो aldehyde से क्या reaction होते हैं? They get oxidized by tolerance, and with KMnO4, aldehydes के reactions होते हैं. The most common one is that they do get oxidized. You've got aldehydes, oxidation होती है, they turn into carboxylic acid with tolerance, Fellings, and K2Cr2O7 or KMnO4. So the first two statements are correct. It's an aldehyde. And then you have another one, which is warm it with alkaline aqueous iodine. So what happens with alkaline aqueous iodine? That's a test specifically for these two functional groups, which are CH3 C double bond O and CH3 CHOH. So इस वाले case में you don't have either one of them. You either need a CH3 right next to a C double bond O and the rest of the molecule, or you have CH3 which is next to a CH or an OH. So the iodoform test is not going to be positive for this particular aldehyde because you don't have a CH3. You do have a CH3, but it's next to a CH2. It's not next to a C double bond O. So इसलिए तीसरा वाला ना, third one is wrong. Several structural isomers of C3H6O3 are listed below. Which statement about these structural isomers are correct? 1 mole of each reacts with 2 moles of sodium. So what does sodium react with? Remember, sodium reacts with two things. Sodium reacts with either carboxylic acids, ठीक है, उसके साथ react करता है. And the other one is that sodium also reacts with alcohols. Uska bhi jo H है ना, it substitutes that H. So that is what sodium does. So over here, यहाँ पे you've got two alcohols. The first one, ठीक है, the first one has. So the first one over here has two alcohols, OH group. So it's going to react with two sodiums. So the 1 mole of each reacts with 2 moles of sodiums. First one ke liye to theek hai. The second one, it's got an OH, it's got another OH. So it's going to react with 2 sodiums. The third one, it's got a carboxylic acid, it's got an OH. So again, it's going to react with 2 sodiums. And the last one is it's got an OH and it's got a carboxylic acid. So it's also going to, so all of them, they react with 2 sodiums. फिर ये कि only one of the isomers contains a tertiary alcohol group. So we have to look for tertiary alcohols are ones where the carbon is bonded to 3 carbon chains. So is there only one? So bari na, the first one, that's a primary alcohol. These are primary because the carbon is bonded to 2 H's. This one is a primary. And this one is a secondary. How can I tell it's a secondary? Ke wo yaad rakh lo ke H se count kar lo ke if you have an OH and there are 2 H's on the carbon atom. Second. So if you have, so always remember count the H's. It's a lot easier to count the H's. If you have 2 H's, that's a primary alcohol. Secondary alcohol has 1 H. Uska na either be H. Or tertiary alcohol mein jo carbon hai, that's not going to have any hydrogens at all. So this one over here is a secondary alcohol. I said this one is a primary alcohol. It's got 2 H's. The carbon has 2 H's. Focus on the carbon. It's got 2 H's. So that's a primary alcohol. The last one is again a secondary alcohol because this carbon over here has 1 H. So if it's got 1 H, it's a secondary alcohol. So only one of the isomers contains it. No one contains a tertiary alcohol group as far as we are concerned. And they all contain a primary alcohol group. No, they don't. The last one contains a secondary alcohol group. This contains a primary. This one contains a primary. The first one contains a primary, but not the last one. So ye bhi galat hoga. So moving on. Bromoethane reacts with NOH. Kaun sa reaction? And that's the nucleophilic substitution reactions of halogenoalkanes. Halogenoalkanes mein if you have a Cl, so OH aa jayega us Cl ki jagah if you have NOH aqueous and reflux, and it turns into an alcohol. So I think he's talking about the same reaction. But he says that it reacts in different ways. So NaOH reacts with halogenoalkanes in different ways. One is NaOH aqueous and reflux, that gives you alcohol. And the other one is NaOH or KOH ethanolic, that would give you an alkene. So you could undergo an elimination reaction, or you might undergo a substitution reaction depending on the conditions. The conditions are kind of very slightly different. Ke aqueous hoga to substitution hogi, ethanolic hoga, that's going to be elimination. So over here with statements about these reactions are correct. So solvent used, if you use water aqueous, so you're not going to get 1,2-diol, because if you have bromoethane, if you have bromoethane, then only one OH is going to substitute the bromine. So it's not going to contain a diol at least. So pehla galat hai. Ethanol, ethanolic. If you have ethanolic, it's definitely going to form alkene. 2 is correct. Because when it's ethanolic, you get elimination and you get a double bond in between. So ethanolic NaOH used, that would do that. Or agar water aqueous use karoge, so you're going to get ethanol. That's also correct, because the Br will get substituted by OH. So ye dono jo hai ye correct hai. Then agla, which compound would produce a carboxylic acid and a ketone when treated with hot concentrated KMnO4? So this is strong oxidation. What happens in strong oxidation? Ki aapka double bond sara ka sara tootega, and 2 carbon chains turns into ketone, 1 carbon chain that turns into carboxylic acid, no carbon chains, 2 H's, that will turn into carbon dioxide and H2O. So iski ab karni oxidation, to double bond ne tootne. So I'm going to redraw this molecule. Aur yahan pe ye. Okay, so I've separated these 2 carbon atoms. This one is bonded to 1 carbon chain, so it will turn into a carboxylic acid. This carbon over here is bonded to 2 carbon chains, this one. So that will turn into a ketone. So it will, which compounds will produce a carboxylic acid and a ketone? So the first one is correct, you're getting both. Isko bhi kar lo ke idhar hi bal ke kar lete. This has 1 carbon chain, so that's carboxylic acid. This one has 2 carbon chains, so that's ketone. So second bhi theek hai. This one, double bond is going to break. This one has 1 carbon chain, so that will turn into carboxylic acid. This one turns into ketone because it's got 2 carbon chains. So ye bhi tino theek hai. Here, next one, you've got catalytic converters are used to modify exhaust emissions from motor vehicles. Which reactions occur in catalytic converter? So catalytic converter ke andar you have, although this is not organic, organic wala kar lete hain. Okay, starting over here. As a solvent X, it's used in printing. So solvent X hai koi. Or molecular formula uska C6H10O4. It may be made by reacting ethane 1,2-diol with ethanoic acid in the presence of an acid catalyst. So an alcohol with a carboxylic acid, that's definitely going to form an ester. So ethanoic acid hoga. So the OH is lost and the H is lost, and in between they're going to link up. So that's how esters are formed. Achha, like in this case, there can be 2 esters possible, because you got another OH and another H lost, and there could be an ester formed over here as well. So what is the structure of solvent X? So because the molecular formula is C6, so there should be 6 carbon atoms, 2 over here, 2 over here, and 2 over here. So it's going to be this one, which is ye kaun sa wala? It's, I think, this is similar to मतलब बीच में going to be अच्छा, that's going to be your answer for this one. फिर 29 है कि which formula represents an ester with the अच्छा with the जो ये clear है, honey, is this clear? अच्छा फिर which formula? कोई question नहीं है किसी के पास? ठीक है, अच्छा 30 रिपीट करें कि उसने कहा था कि there is a diol 1,2-diol. अच्छा नहीं, basically he said there was 1,2-diol. उसने कहा था it was reacting with ethanoic acid. So carboxylic acid and alcohols, they react to form esters. कि carboxylic acid है, that's ethanoic acid. This is this one, and that's your alcohol. What happens? The OH is lost and the H is lost. A condensation reaction happens. Water molecules are produced. और बीच में ester का link बन जाता है. ठीक है, so is this clear? तो अच्छा, लेकिन this was a diol, so there was another ethanoic acid coming from this side, and that was also forming an ester. So it's going to look like this eventually. C double bond O and O, C double bond O and O, and then the molecule, then O and C, then another O and C double bond O. 29, which formula represents an ester that will be formed from propanoic acid on hydrolysis with dilute sulfuric acid? That will form propanoic acid. यानी टूटने के बाद, so the esters will break. The first one is going to form propanoic acid because that's your 3 carbon atoms. So that's 1, 2, and 3. The double bond O will turn into carboxylic acid. So that's propanoic acid. And that's why it's going to be A. This is not going to form propanoic acid. That's 2 carbon atoms. That's ethanoic acid. This is butanoic acid. This one will form an isomer of, it's going to be 2-methyl propanoic acid, but not propanoic acid. So which reaction would not give ethanoic acid? So how many different ways can you form ethanoic acid? Carboxylic acids can be formed from nitriles, and they can also be formed from oxidation of aldehydes. Okay, and there's another one which is esters. You can also form carboxylic acids if you break down esters. So this question में heating ethane nitrile under reflux with sodium hydroxide carbon atoms, and that's ethane nitrile. अच्छा, इसका hydrolysis होगा. You either need sulfuric acid or NaOH. So dilute, it's alkaline hydrolysis or acidic hydrolysis. But the problem is the C will turn into carboxylic acid. But remember, whenever you use alkaline conditions, the carboxylic acid would eventually react. And instead, it will form a salt of the carboxylic acid instead of the actual carboxylic acid. So that will not work. The second one will work. B is going to work. Why? Because as a pehले answer, not. So the rest of the 3 will work. Ethane nitrile, if you heat it with sulfuric acid, that will work. It will give you carboxylic acid. It's going to be the same reaction, except you will get carboxylic acid. That's ethanol under reflux with dichromate 6, aldehyde, obviously carboxylic acid. Ethanol, that's primary alcohol, reflux with dichromate 6, that will also give you carboxylic acid. So ये 3 तो ठीक है. पहला है जो गलत है. As the next one, PQ and R are carbonyl compounds. Felling solution can be used to help identify these compounds. Felling किसको identify करता है? Felling identifies aldehydes. Felling gives a brick red precipitate with aldehydes. So this one is in which compounds form a red brown precipitate. So the first one will, that's an aldehyde. The second one will, it's an aldehyde. The third one won't, because that's a ketone, that's a carbonyl group that's right in the middle of the chain. So that's not going to work. So P and Q ठीक है, बाकी गलत है. I said 26, it's about mechanism. कि propanone reacts with HCN. So this is nucleophilic addition. This is this mechanism over here, that's nucleophilic addition, that if you have a ketone और उसको आपने HCN के साथ react कर रहे हो, so you'll get a cyanohydrin. The mechanism of this reaction is over here, that whenever you have a ketone or an aldehyde, so the carbon and oxygen, you have to remember the mechanism by heart, this one. So the carbon bond is polar. It's positively charged, Cn-1 आता है, वो जाके जुड़ जाता है उसके साथ, ठीक है? And when it goes, the double bond electrons, they get repelled. तो ऊपर O-1 बन जाता है. Then the H+1 from HCN comes in and bonds with the O. So cyanohydrin is formed. So we're going to look for the same mechanism. Sometimes this is written as HCN, sometimes this is written as H+1. तो यहाँ पे वो कह रहा है कि in first stage कह रहा है. The first stage is Cn-1, but remember, you have to be very careful. It's the C and the lone pairs belong to C over here. They're the ones that are going to come in and they're the ones that are going to attack. So ये वाला होगा, it's going to be D. That the carbon group is polar, carbon is slight positive, this is slight negative, and the C has lone pairs, it's got a -1 charge, it comes and attacks. All of the electrons repel होते हैं. So this is exactly the one that we have over here. As a next one, you've got X, Y, and Z are 3 isomeric alcohols. 2 or more of these alcohols react with mild oxidizing agents. One of these alcohols, when dehydrated, will give a pair of cis-trans isomers with the molecular formula C5H10. So which row is correct? So 2 or more of these alcohols react with oxidizing agents. So primary and secondary alcohols, they do react. So 2 or more of these alcohols react with. The third one will not. That's a tertiary alcohol. उसके साथ देख लो, there is no H. So that is a tertiary alcohol. This one is a secondary alcohol. The carbon has only 1 H. Or ये वाला, that's your primary alcohol. अच्छा, तो पहला था 2 or more of these alcohols. तो ये दो react करेंगे. This one will not. One of these alcohols, when dehydrated, will give a pair of cis-trans isomers with the molecular formula C5H10, which is correct. So react with mild oxidizing agents. That's going to be X and Y only, not the third one. और पीछे Y और Z में देखना है किसमें cis-trans बनेंगे. So it's probably going to be Y, because if you look at Y is 1, 2, 3, 4, 5 carbon atoms. So that's 1, 2, 3, 4, and 5. And the OH is right on the middle one, the third one. So when it gets dehydrated, the OH is removed and the H is removed from the neighboring carbon atom. So you get a double bond over here. And that is going to be cis and trans, because this carbon is going to have an H. So दोनों sides different होंगी. इसकी भी दोनों sides different होंगी. So this, when dehydrated, will form an alkene. And that alkene will have cis and trans isomers. 24th है कि chloroethane can be used to make sodium propanoate. So that's a carboxylic acid derivative. So the intermediate Q is hydrolyzed with boiling. तो ये वाला path है कि you have a halogenoalkane, a chloroalkane. How do you make a carboxylic acid? You first turn the Cl, replace it with Cn, and then that Cn can be hydrolyzed to form a carboxylic acid. So he's going to follow that path. So अगर वापस जाए इस पे, you've got chloroethane. So the first step would be it's going to be, so this chloroethane will be substituted by Cn. तो Cl की जगह Cn आ गया. And then this would be hydrolyzed and the Cn will turn into carboxylic acid. But you need alkaline hydrolysis, because you're not getting a carboxylic acid, you're getting a salt of the carboxylic acid. So you'll use alkaline hydrolysis, ठीक है? तो यहाँ पे ना, instead of using H2SO4, you're going to use NaOH because you want a salt of the carboxylic acid. The salt would be formed if you have alkaline conditions. So coming back to this, which CHs will produce the intermediate Q, so that's CN, and that would be KCN ethanolic. KCN के साथ लेके आएंगे, that's going to be halogenoalkane को पकड़ो, CN-1 ethanolic and reflux. That's the answer. फिर ये वाला कि part of the structure of this molecule is given. So in this reaction, this is warmed with aqueous sulfuric acid, producing compound X. Compound X is then treated with hydrogen in the presence of a nickel catalyst. What could be the structure of compound Y? तो हाइड्रोजनेशन हो रही है सिंपल इसकी. तो हाइड्रोजनेशन होगी तो ये जितने भी डबल बॉन्ड्स होंगे यहाँ पे H ऐड हो जाएंगे, बात खत्म. ठीक है, बाकी सब कुछ वैसे ही रहेगा. हाइड्रोजनेशन सिंपल हो रही है, सो दैट्स अच्छा सॉरी, उससे पहले इट्स आल्सो वार्म विद aqueous sulfuric acid. सल्फ्यूरिक एसिड के साथ वार्म करोगे तो एस्टर टूट जाएगा. तो जब एस्टर टूटेगा तो ये टूट के अलग हो जाएगा. दिस वुड फॉर्म CH3OH, अल्कोहल बन जाएगा. और ये वाला जो कार्बन है ना, दैट विल टर्न इनटू कार्बोक्सिलिक एसिड. जब भी एस्टर टूटता है यही होता है कि एक साइड कार्बोक्सिलिक एसिड और दूसरी साइड अल्कोहल. तो द आंसर इज गोइंग टू बी ए, कि हाइड्रोजनेशन जो है वो सारे डबल बॉन्ड्स खत्म कर देगा. सो देयर इज नो डबल बॉन्ड्स लेफ्ट, और वो जो एस्टर ऊपर है वो टूट के इट्स गोइंग टू ब्रेक अवे. तो दैट वन इज गोइंग टू ब्रेक अवे. That's the next one. PVC is difficult to dispose of. Two possible methods of burying it in land and disposing disposable by combustion. PVC hota kya? That's a polymer, and it's a type of polymer that has Cl in it. So rate of biodegradation of PVC in landfill sites, that's going to be very slow. Remember, the carbon bonds are really stable. They don't like to biodegrade. And gaseous products, when PVC combusts, when you burn PVC, you'll get carbon dioxide, H2, and you also get HCl. HCl gas is also going to be produced जब उसकी combustion होगी. ठीक है, there's going to be fumes of HCl that would be produced during its combustion. The next one is you've got how many chiral centers are present. So 4 different groups. This one is chiral. Any double bond that can't be chiral, so I can only find one. That's the only one. Because these carbons over here, they've got 2 H's. Double bonds can't be chiral. So all these carbons have double bonds. This one has 2 H's as well. So that can't be chiral. So there's only one chiral center present. Here in the structure, all of the bonds remain in the places shown. अच्छा वो कह रहा है कि ये क्यूक्यूलर स्ट्रक्चर है. Assuming this is the structure of benzene, how many isomers of dichlorobenzene would exist? So how many isomers? That's going to be 2 Cls right next to each other. So that's 1. Yani number 1 ke Cls jo hai na, they are on adjacent carbon atoms, and that's the rest of the molecule, right? So that's 1. Second would be the Cls are like slightly further away from each other. So that's number 2. The Cls are kind of a baki molecule, so the Cls are kind of really far away. As the third one is the Cls are opposite to each other. So in that case, in that scenario, that's going to be the third one. So you can only find 3 at the moment. Or I've got 3. I mean the third one. Let me draw the third one. The third one is the CLS. Right opposite to each other. Now there could be other ones as well, that Cls could be right next to each other, and there could be a double bond in between. So that could be a fourth one. Okay, the Cls are right next to each other, and there could be a double bond, because we had Cls next to each other, but we had a single bond. But now we have a double bond. So that could be the fourth one. और क्या, और इसमें है कि तो चार तो बन गए, पांच नहीं बनेगा. Cl को इधर लगाओ तो वो, that would be kind of the same thing. It's going to be a double bond and a single bond. So double bond, single bond, you still get the same thing. Cl को इधर लगाओ, कहीं और लगा दो, it's still the same thing. नहीं, there could be another one where, नहीं, that's still the same thing. Cl opposite sides पे लगाओ, it's going to be exactly the same thing. So I'm getting 4 for this. चलिए ठीक है, ये ऑर्गेनिक वाले तो हो गए. अच्छा, किसी के कोई क्वेश्चंस तो नहीं है? किसके बाद we'll start with the. अच्छा, so I'm going to start with question number 1 now. ठीक है, now no more organic. We start with 1. First one is about Boltzmann distribution. That's a Boltzmann distribution. So he's saying, okay, show for the same reaction at a higher temperature. What happens at a higher temperature? कि यहाँ पे higher energy पे the number of particles increase, and lower energy the number of particles decrease, and the curve becomes flatter. ठीक है, it becomes a lot flatter. So dotted line. So I think it's going to be, it's probably B. लेकिन मसला क्या है? अच्छा, H क्या है? अच्छा, the activation, this one. So activation energy change नहीं होगी. The activation energy at the higher temperature would still be the same. So this is the correct graph. That both of these were right in the shape-wise, but the activation energy would remain exact. The activation energy only decreases when you add a catalyst. So otherwise, remains exactly the same. Here, ideal gas equation. What are the units of N and T? So N is moles, and T is kelvins. So it's D. Up here, the reaction between dichromate 6 and Fe2 plus ions results in the production of. अच्छा, अभी जो भी होगी, it should be a balanced equation. So Cr is +6. तो और वहां पे वो +3 है. So I think it's the last one, क्योंकि Cr is +6 and this is +3. So that's a gain of how many electrons? That's a gain of 6 electrons. Why 6? Because you have 2 Crs. Fe जो है ना वो oxides हुआ है, +2 to +3. So it lost just 1 electron, right? So if it gains 1 electron, so there should be 6 Fe's, so that the number of electrons gained and lost are equal. So hence the equation, the correct equation is going to be D. You have to make sure that the number of electrons gained and lost are equal. Cr यहाँ पे 6 electrons gain कर रहा है, plus कर रहा है, ठीक है, that's getting reduced. और Fe वहाँ पे सिर्फ 1 electron, it's only losing 1 electron, so there should be 6 Fe's, ठीक है. फिर sodium azide है, उससे क्या, what are the numbers of electrons in the sodium ion and the azide ion? So sodium azide, that's Na, N3. So Na is +1, N3 is -1. तो अब क्या होगा? अब ये होगा कि सोडियम वैसे तो 11 होता है, that means it's got 10 electrons. 3 ends. How many 3 ends? 7 electrons plus 7 electrons plus 7 electrons. 3 ends. So that's 21 electrons. लेकिन उसके ऊपर -1 का charge is that there's an extra 1 electron over there. So that's 22. So the answer is B, that there are 3 ends, 7 electron each, but they also have a -1 charge. So that means there's one extra electron. अच्छा, अब ये कि next one you've got isotopes का छोड़ देते हैं. Angles, remember the lone pairs would not be given. N is in group 5, so 3 bonds. So that means there's a lone pair, 2 electrons left. Carbon is in group 4, so it's making 4 bonds. All electrons are gone. That's all electrons. Carbon is making 4 bonds again. This is going to be trigonal planar. That's 120. This one is 109 and this one is 107. 109.5 to be specific. So smallest angle would be NX. फिर AE है. फिर percentage mass of 4 different planets given which gases has the greatest density. तो average निकालनी है. Average किसकी होगी? It's going to be CH4 has a mass of 16. Helium has a mass of 4. Hydrogen has a mass of 2. Hydrogen gas has a mass of 2. तो अगर तुक्का लगाओ तो बस अगर वैसे without calculation you want to answer this, so the best one would be C. ठीक है, क्योंकि 2.3% that's the highest percentage of methane. And it's also one of the highest percentage of helium as well. So this would be the heaviest, because obviously it's got heavy gases, more of them. So you don't even have to do calculation. वो वैसे ही पता लग गया कि भाई ये दोनों gases heavy थी. फिर है कि how much energy is released per day, every day. तो वो कह रहा है factory makes for every mole of O2. तो वो कह रहा है कि इतने moles produce हो रहे हैं. पहले तो ये कि you have to figure out the moles of O2. You know the moles of NH3, so the 4:5. So multiply this by 5, divide this by 4. So you'll find the moles of O2. Once you have the moles of O2, तो एक मोल का पता है इतनी एनर्जी होती है, तो 181.8 kilojoules. So you multiply this. So the first thing is you find the moles of NO, and using those moles, they're already given. Using those moles, you find the moles of O2. तो 4:5 है, तो उससे आपने लगा लिया हिसाब के इसके कितने मोल्स होंगे O2 के, और फिर आपको पता था कि O2 जो है ना वो इतनी एनर्जी प्रोड्यूस करता है. ठीक है, इसका C है. अगला कर लेते हैं कि what happens in this reaction? So is the oxidation state changing or not? I don't think it's changing. कि यहाँ पे CrO4 जो है वो that's -2. We have to be careful. I think it is changing. Fe यहाँ पे I think was Cr2O4. यहाँ पे Fe is +3. Na is obviously +1. Carbon dioxide is produced. Cr over here is +6. इस जगह पे. और Fe over here must be +2, and Cr would be क्या होगा यहाँ पे 2O4. So it's Cr2O4 2 minus. अगर Fe को निकाल दो तो that's so that is Cr. क्या बन रहा है? Cr -8 +6 बन रहा है. अच्छा, इसका मतलब है एक बात तो क्लियर होगी कि Cr ऑक्साइज नहीं हो रहा. Cr पहले भी +6 है. So chromium is not oxidized. Chromium is gone. Only iron is oxidized. Iron was +2, and over here iron is +3. So there's only one element that is getting oxidized. अच्छा चलो, ये इसका हो गया. फिर ये अब कल कंटिन्यू करते हैं पेपर. ठीक है, चलो, ओके एवरीवन, हाफिज.